This is Advent of Code, day 12, and here we go. Passage pathing, submarine, subterranean system, optimally. Best path is to find all of them. Sensors are still mostly working. Build a rough map. Okay, so we have paths, number of distinct paths that start at start and end at end, and don't visit small caves more than once. So all paths you find should visit small caves at most once and can visit big caves any number of times. Start A, C, A, end. Okay. Dests equals hash.new. Okay. And big caves equals set.new small caves. Okay. SE equals stir.split. Dests. Dests E, and then if S equals S dot downcase, small caves, S else caves, ES. Okay, paths equals set.new. Partial paths equals start. Okay, partial paths puts paths dot count while path equals partial paths dot pop. Path set.new. Path visited equals partial paths dot pop. Current equals path dot last. And then we want to dests current dot each do dest if dest equals end else paths path plus end Otherwise, if visited, if small caves dot include dest and visited, not include dest. Visited current if small caves dot include current. So if it's a small cave and you haven't visited, if it's not a small cave or you haven't visited, then partial paths path plus dest visited dot dupe. Puts found path full path equals path plus full path example 1 10 paths. Cool. Uh, 5157. Yes, 716. After reviewing the available paths, you realize you might have time to visit a small cave twice. Okay. Z hash dot new. Oh. So now this time, instead of this, it's going to be z hash dot new visited counts, visited counts current plus equals 1. Counts equals z hash dot new counts start equals 2 counts, just to make sure we don't visit start twice, and or visited counts dest less than 2 counts. Um, 54. Puts paths.toA.sort. toA.map. I got 54. AB, AB, AB. Oh, a single small cave twice. False. If current not equal path visited twice, start and visited accounts current equals 2, visited twice equals true. Or not visited twice. If current not equal start and next and visited next if visited twice. Uh, 144,309. Boom. 1320. Puts. Let's see how that would have done. I think it was like 715 and then 1320. Okay, wouldn't have made it. Nope. Dang, people are good at this. All right, let's discuss. Cool. I can get rid of those. All right, day 12, passage pathing. With your submarines, subterranean subsystems subsisting suboptimally, the only way you're getting out of this cave anytime soon is by finding a path yourself. Not just a path, the only way to know if you've found the best path is to find all of them. Fortunately, the sensors are still mostly working, and so you build a rough map of the remaining caves, your puzzle input. This is a list of how all of the caves are connected. You can start in the cave. You start in the cave named Start, and your destination is the cave named End. An entry like B-D means that cave B is connected to cave D. That is, you can move between them. So the above cave system looks roughly like this, and this is just converting this into a graph. Your goal is to find the number of distinct paths that start at start, end at end, and don't visit small caves more than once. There are two types of caves: big caves, written in uppercase like A, and small caves written in lowercase like b. It'd be a waste of time to visit any small cave more than once, but big caves are large enough that it might be worth visiting them multiple times. So all paths you find should visit small caves at most once, and you can visit big caves any number of times. And then there are some examples. How many paths through this cave system are there that visit small caves at most once? So we have our input. And do I ever use big caves? Nope. Whatever. So we're going to have a map we're going to map each node to all the things that are reachable from that node. That'll be our destinations. And then we'll have a list of big caves and small caves. I don't end up using the big caves. For each string, we split on dash to get the start and the end. We add the end to the set of things reachable from the start, add the start to the things reachable from the end. If it equals its downcased version, then we add it to our list of small caves for both start and end. Cool. So now we want to figure out all of our paths. So for each path, this is going to be a set of all paths, and we're going to basically have a bunch of partial paths that we're going to loop over. So while we have any partial paths, this is an array with one element, or one partial path. That one partial path contains the actual partial path, which is just start, and then the set of things the set of small caves that path has visited. So we get our current partial path, which is the path and then the visited nodes. We get the thing that it's currently at, which is the last thing, and we add that to our set of visited nodes if it's a small cave. Then for all of the destinations from that thing, if the destination is the end, then we'll add the path plus end to our set of paths, full paths. Yeah, breath first. Yes, breath first search. I have never really like I can explain breadth first search versus depth first like with a drawing, but like when I'm writing these, when I'm like searching, when I'm trying to write these solutions, I definitely don't think of it as like breadth first search or depth first search. But yeah, I guess this is breadth first. So we add our full path to our list of paths. Otherwise, if the destination is not the end, if the end is not a small cave, or we haven't visited, if it's not a small cave, or we haven't visited that destination, then we will add that to our set of partial paths. We'll add that next destination to our path and carry on with a copy of the things that we've visited. And then that just works. And eventually this will like run out of things because like I suppose he takes care that I imagine he makes sure that there are no big caves that are connected to other big caves. Because otherwise you could just ping pong back and forth between two big caves endlessly. And then it would be an infinite number of paths. So the big caves are only connected by small caves. So this will eventually run out of partial paths. Because eventually every path will have visited everything, and so this will never be true. Yeah, and so that's part 1. part 1. So now, part 2, after reviewing the available paths, you realize you might have time to visit a single cave twice. You can't visit every cave twice, but you can visit a single small cave twice. But you can still only go to start and end exactly once. So the way I did this is originally I wrote it as you could visit every small cave twice, and then I kind of had to like hack to make it. Ended up being much uglier than if I had just understood that from the first, maybe from the beginning. I don't know. So now it's basically like the same approach, but now instead of a thing keeping track of what I don't know, I was like 40 seconds off, and I don't know if like I was 40 seconds away and probably trying to do this from the beginning. It like is very possible that I would have messed up just because it's different. So now I'm going to keep track of how many times I've visited each thing, and whether or not I have visited something twice. Yeah, I guess. Yeah. So this is just the number of times I've visited everything. So now I loop over all my partial paths. I get the visited counts and whether or not I've visited something twice. So we don't care if current is start. We don't need to do anything special there because that only happens at the beginning. So if the current is not the start and we're in a small cave, we'll say that we visited that cave more than once, or once more. And if we've now visited this cave twice, then if we've already visited something twice, we stop because this is now no longer a valid path. But now we have visited the current cave twice, and so now visited twice is true. And so when we pass it, when we add it to our stack of things, it will be true. So now we again loop over all of the destinations. Same thing, same way we handle the end. We add it to our full path. Also, what does my input look like? Okay, not too long. Yeah. So now if it's not a small cave, or we visited that cave less than twice, this is just, yeah. If we have visited it less than twice, then we will keep going. And visited twice, yeah. So now instead of, our state is how many times we visited everything, which we increment every time we visit something. And then we also keep track explicitly of whether we visited something twice. It takes a while. Yeah. I think I can make it a little bit shorter by doing this, because this causes, so that was like 6 seconds. Oh, okay, that did not make it much faster. Yeah. Or, yeah. Basically, I could make it faster by checking the visited twice thing here and skipping the visited counts dupe, because this is expensive, duplicating the counts. Yeah. I think that is like the main thing. Yeah. Basically like short circuiting. This term was used when I took in like my second CS class where we learned recursion. Like tail arm or long arm recursion. Basically, we're like, if you have some sort of recursion thing, if you have any sort of recursion, then you should try to handle all of the cases like at the beginning in your base case, and like don't duplicate your check when making the recursive call. But in this case, like checking again here would avoid the duplication. So yeah, that's that. It does take a while. I don't think that's not how time zones work. They're released they're released for the day before. Yeah, so that one was close. I would have been close to the leaderboard, but not quite. Yeah. So you don't think that these extra arguments are redundant? I mean, like, I can infer these from the partial path, but yeah, I don't know if that makes it that much faster. Anyway, yeah, it works. Cool. So that is Advent of Code, day 12.